converting units of measurement. So there's a table you have to get familiar with. So in this table, there's prefixes you have to learn. So there's deca, hecto, kilo. So these are the prefixes, and it tells you what to multiply to convert one to the other. So let's do an example. So how to use the conversion table above. Right, to use the conversion table, this is mega to centi. So let's find where mega is. Mega is this, which is 10 to the power 6. And to centi, which is 10 to the power negative 2. So what you do is, to go from top to bottom, you have to multiply. Okay, it says multiply. So because you're going from mega to centi, you're going to multiply by. Now, see that you find the difference between 6 and negative 2. So 6 minus negative 2 is 8. So you have to multiply by 10 to the power of 8. Yeah, like that. Let's make that bigger. So 10 to the power of 8. Now, if you want to convert from micro to kilo, again, look at the table. Micro is over, let me use a different color pen. Micro is over here, 10 to the power negative 6, to kilo, which is over here, 10 to the power 3. So you find the difference. So the difference is, again, you do big minus small, so 3 minus negative 6, there's a difference of 9. So in that case, you have to divide by 10 to the power of 9. Okay, so to convert from micro to kilo, you have to divide, because going from bottom to the top, you have to divide by 10 to the power 9. Okay, now you know how this table works. Yep, or you can also do times by 10 to the power negative power. They will get the same result. All right, let's look at some questions. So the first thing is, we're going to use this table to convert the units. So in this question, we're going to convert 3 minutes to microseconds in scientific notation. Notice the shorthand for microsecond is not ms, it's that symbol. That's a Greek letter, mu. So that Greek letter means microseconds. So we're going to first convert 3 minutes to seconds first. So to convert to seconds, you have to times by 60. So right, times by 60, you will get 180 seconds, right? Now going back to the table, if I want to go from seconds to microseconds, so think of seconds is over here, that doesn't have any prefix. So if it doesn't have a prefix, your starting point will be this part of your table. So let me rub this off. So you start from here. So that's where you start. And because you are going to go micro, you have to go down. Right, go down. And because going down, you are multiplying. So you're multiplying if you're going down. And you multiply by 10 to the power of 6. Oh, actually, you times by 10 to the power of 6, because you find the difference. So that's a negative 6, that's level 0. So you go 0 minus negative 6, that becomes positive 6. So you times by 10 to the power of 6, which you can do on your calculator. Actually, you don't even need to do that, because your final answer is in scientific notation. So do 180 times by 10 to the power of 6. But that's not in scientific notation yet. So what you need to do is, there's 2 digits after 1, so you're going to add 2 to the 8. So adding 2 to the 8 becomes 8. Adding 2 to the 6 becomes 8. So you get 1.8 times 10 to the power of 8 is your final answer. All right, any question? All right, that's changing from seconds to microseconds, so just check the differences. So going from here to there, there's a 6 level difference. So it times by 10 to the power 6. Then you have to change that to scientific notation. Okay, good. All right, after we finish, we're now going to do another question. This time we're going to change from nanoseconds to nanoseconds. So we're going to change 3 minutes to nanoseconds. So what you do is, you write this as 180 seconds like before. But let's check out the nanoseconds is 10 to the power negative 9. So there's a difference of 9, right? So you go times by 10 to the power of 9, right? And then you go 180 times 10 to the power of 9. To convert to scientific notation, you have to add 2 to the power. So your answer will be 10 to the power of 11. So you write 1.8 times 10 to the power of 11. Yeah. Any question? All right, so now we know how to change from big to small. We can also change from a small unit, milligrams, to tons. Okay, so what do we do? First, we have to convert to grams first. Milligrams to grams. So we'll look at the table. Milli is over, let's rub this off. So milli is here. We're going to go to grams. So gram doesn't have a prefix, so you go over here to the blank box. So the difference of 3, right? So in this case, you have to divide by 10 to the power of 3. So when you divide by 10 to the power of 3, same as dividing by 1,000, so you go back 3 steps. So you end up with 4 million grams. So 4,000 million milligrams become 4 million grams. Like that. And then you now know that from grams to kilograms, you can use this. From grams to kilos, C is 10 to the power of 3. You have to divide by 10 to the power of 3. So you go divide by 10 to the power of 3. So that will be 4,000 because you move the decimal places 3 steps to the left. Now, the ton is not there's no prefix, so you need to know this off by heart. The difference between kilogram and ton is 1,000, so you have to divide by 1,000. So that's not a prefix, that's just a knowledge you have to know. So divide by 1,000, so it will become 4 tons. Okay, any question about prefixes? So make sure you refer to this when you do the homework. All right, so that's converting units of measurement. We also need to do another exercise today so that we can keep up with the program. So this is a short exercise. You can finish that easily. Let's move on to the next page. 1B, accuracy of measuring instruments. All right, hopefully you're all ready. Okay, let's make this big. All right, turn around. Okay, turn around. Okay, accuracy of measuring instruments. Now, to understand this, let's do a introduction to this part of the exercise. First, I want to round to the nearest centimeters. So 5.5 is to the nearest centimeter is 6, because that first decimal place is 5 or more, you round up. 5.6 is also 6. 5.7 is also 6, isn't it? All these are 6. How about 6.0? 6, 6.1, 6. They're all 6, isn't it? Okay, that's the plan. Okay, now listen carefully. This part can be confusing. So listen very carefully. So when we measure the length of an object to be 6 centimeters to the nearest centimeter, the actual length. So when someone say that the length of this line is nearest centimeters to 6 centimeters, this could be any the actual length could be any of these numbers, isn't it? Because all these numbers round to 6. So the actual length could be 5.5, or could be 5.7, or could be 6.3, right? So what we're going to do is to write down the limits of accuracy, a range of values that the actual length could be. So for this question, the limits of accuracy tell you what the upper and lower boundaries are for the true measurement. So in this case, the limits of accuracy is, so the lower bound is 5.5. So when something is measured to the nearest 6 centimeters, the lowest it can be is 5.5. Can't be lower than that. And what's the highest it could be? Yeah, 6.5. Yeah, but it's going to be long. So we just, for simplicity, I'm going to write 6.5. So the highest it could be is 6.5. The lowest it could be is 5.5. This is the actual measurement. The actual measurement is anywhere between these two values. So how do I do that in a quicker way? So all you have to do to find the limit of accuracy, you just have to do 0.5 or half of the smallest unit. So in the above example, because it's rounded to the nearest centimeters, the smallest it could be is 1 centimeter, if it's rounded to the nearest centimeter. So all you have to do is just do half of 1 centimeters and do plus and minus. So that means the lower limit will be minus 0.5 to this from the 6. The upper limit will be 0.5 plus 6. So the actual measurement could be anywhere between 5.5 or 6.5. So this is the limit, the limit of accuracy. The range of values the actual measurement could lie in, right? Okay, so now we're going to calculate the limit of accuracy for these measurements. So what you need to do is to write down what the smallest value it could be, what the highest value it could be. All right, let me see. Okay, so in that case, 72 centimeters. Looks like that person has rounded to the nearest centimeter. To the nearest cm. So the smallest unit is 1 centimeter. And to do our limit of accuracy, you have to go 72 minus 0.5 times 1 cm. That gives you the lower bound, which is 71.5. That's the smallest this measurement could be. And the highest it could be will be plus 0.5 times the smallest unit, in which case it is 72.5 cm. So this is the limit of accuracy. All right, any questions? Right, all good, very good. So when you're ready, I'm going to do another one. So we've done an example that involved a measurement being rounded to the nearest centimeters. We're now going to do an example where it is rounded to the nearest 1 decimal place, which is the nearest 1 decimal place of a millimeter. So what you need to do is the smallest unit, in this case, will be correct to 1 decimal place, 0.1 mm. So to get the limit of accuracy, we'll do 86.6 minus 0.5 times 0.1. So you take half of that, which you can use with your calculator. So I'll just bring this up. So you do 86.6 minus 0.5 times 0.1. That gives you 86.55. So the smallest it could be is 86.55 mm. And the other one will be plus. So 86.6 plus 0.5 times 0.1. So all you have to do is just go back. Don't have to type this again. Change the minus to a plus. Equal. You get 86.65. So in general, if you see the two examples, when you get the limit of accuracy, it's almost like adding an extra digit there, isn't it? Putting a 5 there. And you have it jumps between 5 or 6, 5. Same as the other one. Jumps between 1.5 and 2.5. Yeah? So you can just see the pattern. Okay. All right, now we know how to calculate the limit of accuracy. We're now going to do an example. So this one's a bit longer. So we're going to do that together. Okay, so let me get a student to read. So raise your hand if you want to read. Anyone? Maybe pick a student. Maybe I ask year 10. Oh, there's my screen time. Okay, maybe ask a new student. Jasmine. Yep, thank you. All right. So what we're going to do is find the upper-lower limit of accuracy for the sides of the square. So first, you find the smallest unit. And the smallest unit, because it's rounded to the centimeters, the smallest unit is 1 centimeter. So what you need to do, so the smallest unit equal to 1 centimeter. So what you need to do is the lower limit can be calculated by doing 6 cm minus 0.5 times 1 cm. Okay? And if you do that, you should get 5.5 cm. And the upper limit can be done by adding 0.5, which is 6.5 cm. This is the lower and the upper limit. Once we get that, this is the upper and lower limit of the size of the square. We now have to find the upper and lower limits for the perimeter of the square. So for the perimeter, the smallest the square could be is, it's a 5.5 by 4.5 square, isn't it? So the lower limit for the perimeter equals to 4 times 5.5. So the smallest perimeter it could be is 4 times the smallest length, in which case, which is going to be 22 centimeters. And the highest perimeter it could be upper limit perimeter. That will be 4 times the longest side it could be, which will be so 4 times 6, 24, add to 26 centimeters. Like that. Any question? And you can do the same thing for the area. What's the smallest area it could be? What's the largest areas it could be? Just by using the smallest and the largest side length respectively. Yeah. So let's try that. So write down lower area, upper area. Okay, have a try. So on your calculator, there's a dedicated square button. So all you have to do is to press 5.5 square. Gives you the lower limit, which is 30.25 square centimeters. And the other one is 6.5 square. All you have to do is just change the 5 to a 6. You get 42.25. So that's the largest area it could be. That's the lowest area it could be. Okay. Any question? You did exceptionally well today. You're all very cooperating. So there's 2 exercises you have to do. Now before you start, hang on, listen.